Sounds
Okay.
good.
Okay, so we're good to go. Questions 1 and 2 are pretty easy.
Mm-hmm.
Then on question 3, it says, what is the symbol for the true population proportion? It's either...
What week are we on real quick? Sorry, I'm just pulling up the quiz.
Oh, yeah. I'll wait until you get up there. We're on lesson 7.
9.
So week 9.
9, lesson 17.
Yeah.
Okay. All right, I'm ready to go.
Okay. So that first question, I'll read it off again. The symbol for the true population proportion is one of the following. Or which of the following? P with a squiggly, P hat, or P. I put down P because that's what we've had in the past.
Yeah, it's
Yeah.
the true.
Is that what you guys agree about that?
Yeah.
Yeah.
Okay.
I got the next one. So we're supposed to use this n equals 100, p equals 0.25, and triangle p equals 110. The requirements for constructing a confidence interval are satisfied. I think it's do you guys think it's is it true? It looks like it.
I think it's true. If
Yeah.
you go to the textbook, it says to figure out whether or not the requirements are met, you have to check using that n p hat is greater than or equal to 10, and the opposite one that's like n times 1 minus p hat is still greater than or equal to 10. And I did that, and it's at least 10 when you do the first part of it. So I think it's true.
I think it's true too.
Me too.
And then on question 5, it says the requirements for conducting a hypothesis test are satisfied. And I'm trying to remember. I think I saw that somewhere.
It's
It's down here. Oh, it says we can test the question using a hypothesis test if the following conditions are satisfied. And it does the same thing. Oh, no, it does NP without a hat.
yeah. It's NP is greater or equal to that one.
Yeah.
And
So let me do this real quick.
parentheses 1 minus p is greater or equal to. And it's supposed to be 10, right?
Yeah. So the first one checks out.
And then when we do the second one,
Or minus 0.25. Yeah, that still checks out. So the requirements are still met.
yeah.
So true on that?
Yeah.
You know where we got that, Jeremy?
I was trying to find it on the textbook. Where did you find it?
Yeah, so when you go to, if you're looking at this chapter, you go to hypothesis test, it'll be under contents, it'll be under 4, you just click under that, and then it will bring up the steps, test 1, and then you just scroll down a little bit more after those pie charts, and step 4 shows you if the following conditions are satisfied, and it's like NP is,
Greater than or equal to 10?
Yeah.
It's,
Okay. Yeah.
But it's not NP hat. It's just NP.
it's just
Yeah.
NP, so make sure you use the right one.
Okay, so question 6. Using the following information for the next 5 questions, a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. So find P hat, the point estimate of the proportion of first-degree murder defenders who were found guilty in this state. So for this one, I kind of did the same thing that we get when you check for p hat, where you do the x divided by n. So I used 45 divided by 60, and I got 0.75.
So you did 45 divided by 60.
Yeah.
You got 0.75?
Yep. Let me do
Yeah,
it
that's
again.
what I got too.
Me too.
Do you guys think that that's correct, or?
So where did you get the? Is that on the textbook, the equation that you used?
Yeah, if you go right underneath confidence interval, this is what we learned in the last chapter as well. Hey, Kazuya.
How far have you guys got?
I think we're just on question 6.
Okay.
So the first two are the
I see it.
main
It's under
questions.
2.2. Is that what you're talking about?
Yeah. So underneath it, it says where p hat is equal to x divided by n. And so that's what we learned in the last chapter too.
Mhm.
So I just did the 45 because that's our like sample proportion divided by n, which is our sample size.
Yeah.
And I got the 0.75 on that.
On
Yeah,
number 6?
Yeah.
Okay.
Do you want us to backtrack a little on 3, 4, and 5, Kazuya?
If it's all right with you guys.
Yeah, that's fine.
Yeah.
So on question 3,
It's the top one?
we got
Is it just a P?
just p.
Okay. We're satisfied. That would be true.
That's what we got.
Okay. We're conducting hypothesis are satisfied. That'll be true as well. Right?
Yeah.
Okay. All right. Good.
And then 0.75 on that other one.
Yep.
Okay. Question 7, create a 95% confidence interval for the true proportion of first-degree murder trials in this state where the verdict is guilty. Input your answers for the margin of error, lower bound, and upper bound. So we got to figure this one out.
Okay, what did you guys do the z square root of p times 1 minus p divided by n?
Just 1 second. I'm still working on it.
Then I think we have to find a z-score for that.
So we got to get the margin of error. So the z one is where did I see it?
It is the p with the top hat minus the z-score of the square root of p with the top hat times 1 minus the p with the p in the triangle divided by n.
Yeah, so on these ones, because we already know what z is,
What is our z?
that's the 1.96 z. The
Okay,
z
that's what I
portion
got from the
is
z.
the confidence interval.
Yeah, that's the z-score of it. Then what did you get for RP?
Well, let's see. P is up on top. It's 0.25. Oh, nope. Psych. Sorry. Different one.
I know that's what I couldn't figure out is what P is.
Isn't P the same as P hat if our random sample's the same size?
We don't need to know our just regular P, do we?
Well, I think you do because when I looked at the formula, it's like M equals Z times the square root of P
That's
times.
for something else. That's not for the confidence interval.
Are we
Yeah.
doing
Yeah.
confidence again?
It's asking for margin of error, though.
That's asking for a margin of error
Mm,
because that's how you do the margin of error.
Oh, yeah.
Oh, wait.
Yeah.
Hold on. If no prior estimate for P is available, we can use the following formula to compute our sample size. What?
Ah, joy.
Sample 60. I'm guilty.
No, Jeremy, did you get the what you call it, the lower and upper bound for it?
not yet.
Yeah.
I'm still trying to figure out how to do the formulas for that.
Well, I have to finish my homework real quick. Well, because I didn't think
So,
just finish
we don't.
I didn't think it would take this long. So I'll just really get it right there. I'll just get it right there.
Okay.
Yeah.
So, formula is P minus
So
Z score times square root of P times there's so many P's.
And I'm trying to figure out. I think we just use a normal P. Then I don't know if I normal P.
And what's the N? Was it 60?
Yeah.
Okay.
I think that I think that I figured it out.
Or, as much as
So,
it has to be.
I think that
I mean, if
in mine, I assumed that um, P with the hat is the same as P in this instance because we don't have it.
Yeah.
So I then plugged that in, so the 0.75, and did it through the whole thing, and I got 0.110. And then just to double check on that, I kind of did the same thing that Jeremy did in one of those tests that we did in the past, where you subtract the confidence interval, the higher upper bound by the lower bound. And
I
divided by
was looking at a wrong formula. I was looking at the lower bound formula.
Oh, gotcha. For this test?
Yeah.
Oh, gotcha. What did you get for it then, Jeremy?
Or wait, no, I was looking at the wrong formula, so I was doing something wrong for the margin of error.
Oh, gotcha.
So
Gotcha.
I know what the lower bound for margin of error is.
What did you get for it?
0.640.
That's what I got too.
What'd you
And
get?
then 0.640.
640. Yeah, that's what I got. And for the high bound, I got 0.860.
Yeah, so the way that I double checked for the margin of error is I just subtracted 0.860 by 0.640 and then divided the answer by 2.
Yeah.
I got 0.110. Because that's what Jeremy did in that one thing. That's what the only time that we got that margin of error right.
Only time.
So the upper bound is 0.860,
Yeah,
Mm-hmm.
and the lower bound is what?
0.640.
And then you said then we got 0.001. You said
0.110.
And
So
can you
I-
repeat that? How you get that?
and I got
So
0.11 rounded to 3 decimal places, right?
yeah, that's how I did it as I rounded it to, because it's
Yeah.
like
So
1.095 or something like that.
did you
But
do
then
the whatchamacallit? Did you do the formula to get the margin of error?
Yeah, I used the formula first, the one that was in our textbook.
Mhm.
And then to check that, what I did was I went through so we're supposed to be using a categorical data analysis Excel spreadsheet now that I opened up. It's inside the textbook. And I plugged in that the null hypothesis was 0.75 because that's what they're asking us, and put in the numbers. And I got the 2 confidence intervals that everyone else got. And then I did 0.860 minus 0.640.
Oh yeah, I just plugged it in. I created a formula myself to find it. That's all I was just asking.
Oh, what did you get for that? Did you get the same thing?
Yeah, I got 0.110.
Okay, yeah. So
Yeah.
mine was just the same steps that you're doing. It's just I did it manually.
Yeah, I got the same thing
Okay.
because I plugged it into Excel. I just created something off the formula. So what's the next?
Okay, for question 10. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
That'll be narrower.
So it would
I think it might. Do you think it would stay the same though? Unless that's a huge jump. I don't know.
Hold on, let me check.
If the
Okay, so low bound increased and the high bound was decreased. So it's
yeah,
it's decreased.
it will decrease, right?
Mm-hmm.
Yeah.
decrease.
Yeah.
Okay, number 11. To conduct a hypothesis test for one propulsion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest n and both requirements still be met?
Okay. So this is basically we just have to do that requirements test
Okay, well, let me help with something. They'll brainstorm.
where you do the NP divided by
Oh
or
yeah,
the
okay.
so
Sounds
see it's
good.
1/2, so it's 50. So let's say 100 times 0.50.
That's
So 50 times 0.50 gives us 25. 25 times 0.50 is 12.
Like that. You know, about something.
So like it's got to be like 20 times 0.50. Yeah, so it's 20. 20 is the smallest n you can have for the first one to be met.
How did you figure that out?
I just did a trial and error to where the first one that we have is the n times p is greater than or equal to 10.
Mhm.
So then what I did is, since it's 0.5,
So
the size is going to always be halved to create what the 10 is. So
Oh,
basically, you have to find what the smallest one has, what the smallest n can be halved to equal 10. So 20 times 0.5 is 10. So that's what I got on that.
yeah, that makes total sense.
And then the other one is like 20 times 1 minus 0.50.
Okay, I didn't know.
Yeah. So yeah, it's 20.
Yeah.
so next one is 100.
What'd you say?
Number 12. I got 100 on next one.
Me too.
I thought this is. Yeah,
Yeah, that
Yeah.
sounds right.
that's true.
Yeah, put something else to do.
Okay, number 13. We collect the data, new data, and this time n equals 80 and x equals 38. And you get good health. The conditions for conducting hypothesis tests are satisfied. True or false?
Okay, so we got to do the same thing. So 80
Okay.
times 0.6.
Yeah, it seems like lately he just likes to sleep on my
80
chest.
times
on my lap.
1 minus 0.6.
Not that I
It's
can.
48.
Yeah, so that's
So it's true, right?
yeah, that's true.
And what is the p?
And then for that, you just do 38 divided by 80.
Yeah, 30.
I'm gonna just check this with the.
0.475.
Yeah, that's what I
Yeah,
got too.
0.475.
You got what?
475.
0.75?
0.47.
Okay. Sorry, you keep cutting it in and out.
We have a 95% confidence interval. 6, and that's.
Wait.
So I'm just gonna put this in here. Yeah, 0.475.
So are we gonna use quantitative inference procedures file?
No, there's actually one on the textbook
Yeah.
called. If you go to, I think it's. Oh yeah, if you go underneath
Yeah, the summary.
if you go to the summary,
Which
Then
one
go-
is it though?
go to confidence interval for one proportion, and then go to 2.2
Confidence.
or 2.3. Yeah, do 2.3, and then inside there, it'll say that the finding the confidence interval
Oh,
in proportion is tedious. There's a categorical data analysis Excel that has the exact the exact thing that we will use for stuff like this.
okay. Because I was just making up my stuff, so. Okay.
Yeah, are we on 15? Is that the one we're on right now?
Yes, you are.
Are we on 15 right now, guys?
No.
Yeah, I think so.
Okay, sweet.
Okay, find the test statistic. So, are we just doing the one proportion then?
Yeah, just
Okay.
one proportion. So let me double check how to get a test statistic on this
So
stuff.
a test I have the formula pulled up. It is It's equal to the p with the triangle on top minus p divided by the square root of p times 1 minus p divided by n.
Is that the test statistic, or is that z-score?
It says the test statistic is, and that shows a formula with z equals value minus mean divided by standard deviation. And then it goes on to saying equals p with the triangle minus p and so on. It's under, what section? It's under step 4, close to where that NP greater than or equal 10 is, where we were just a little bit ago.
Oh, gotcha.
Do you-
Oh yeah, I see what you're saying. Okay, so
Hmm?
let's see.
So what's our p?
P is
You mean the triangle P?
Just the regular p.
it's
Oh.
0.06 or 0.6.
0.06, you said?
0.6.
Okay.
And then our p hat is 0.475.
Yeah.
So
So then, what is our test statistic?
it's the value minus the mean. So 0.475 minus 0.6 divided by the square root, but divided by the standard deviation, which is the square root of p times 1 minus p over n. I'm going to just plug that in.
Oh, you mean the
This is-
on the step 4, number 18? Is that it? No, that's the z-score. All right. Where are you guys
no.
finding this? I can't see anything.
Yeah, me
P
either.
is 6. It's under step 4.
If you hit Control Find and just type test statistics, it'll just show it right there. That's how I found it. And it says the test statistic is, and it gives the formula.
Root, so that's what we need. And this is going to be. So what is?
Okay, gotcha.
Okay, so this is what is this? 0.475 minus.
Hmm.
0.475 minus 0.6 divided by the standard deviation. I got negative 2.282, which I believe is the same as the z on the one sample z test for proportion.
Hmm.
Did you get the same thing?
I think I did my formula wrong. 1 second.
So for the test statistic, you said you got negative 2.82
I got negative 2.282.
or negative 2.282.
Yeah, which is the same one as what you get if you go through the categorical data analysis test. So that z is equivalent to our test statistic.
Hmm.
P-value.
I don't know. I'm getting negative 10.479.
Did you square root your standard deviation thing?
Yeah, so what I did is I did 0.475 minus 0.6 divided by the square root of 0.6 times 1 minus 0.6 divided by 80.
Okay, so Square root of that. 0.6 times 1 minus 0.6 divided by 80. Then 0.475 minus 0.06 divided by the standard deviation. Yeah, I don't know how you got that.
Okay.
I
Yeah,
got-
I agree with what you just said. That our t-score is a z.
So, Jeremy, let me see if I understand this right. So, on the top portion, you have 0.475 minus 0.6
Yeah.
divided by the standard deviation.
So instead of that, I just did the square root. And then I did the formula. Just like how the lesson book says.
Yeah. Did it just square root the top portion of it, or did it square root the whole thing?
Just the bottom part. Just the...
Yeah, I'm saying, did it square root just the top portion of your standard deviation, or did it square root the entire part of it?
I don't know. Let me get... I think it's Excel.
Okay.
Let's stand up.
Here, I'll screen share
So,
mine.
hey guys, I just submitted it, and negative 2.282 is right.
Okay. Here,
And I got
Jeremy.
I got 100% on that. So
And it's a negative 2.82, you said?
282, yes.
What did you conclude on? If
Mhm.
it's 1 and we're doing 95%, did you reject the null hypothesis?
You mean number 11?
17.
I mean 17. I reject.
Yeah.
Reject the null hypothesis.
Which means that we have sufficient evidence to conclude
Yeah.
that water has not decreased.
It actually has decreased.
So is that the last one?
Mm-hmm.
Yeah.
What was 16, the p-value?
Are you using the file that was on the
No, I'm
textbook?
just doing it by hand.
Okay, well, if you get the file, everything is gonna come up for you.
Okay.
But I got it as in 0.011.
Okay.
That's also what I got.
Okay. I'll try to figure out what I did wrong. I bet it's just Excel doing something.
Yeah. What did we get for 16?
16 is 0.011. I don't understand why they kind of switches the what is the T and then they ask you for Z. I don't get it.
What were you saying, Kazuya?
I don't get why they switch up what they're asking. I mean, in this case, they're asking for the T score, but our formula is for the Z.
Are you saying test statistic?
Is it test statistics?
Because
Yeah,
that's what
test
Z.
statistics. Yeah. Because
It's just hard because they use the same letters for tons of different things. They use the z-score, but they also have the confidence interval that we multiply by. It's just confusing sometimes.
just shoot me. English is not my favorite. Let's just put it that way.
Gotcha. So I got 100% on that too. Before we are done today, do we want to talk about who wants to take different parts of the project? Like who wants to be main writers for the different projects, and then who wants to, or what kind of hypothesis test do we want to do?
Sure.
Yeah.
Okay.
Why should I have to? Why can't you just?
Okay, so first things first is I need. So we've got 3 other things aside from designing the study and the PowerPoint, which I'll do both of those. We have to have a main writer for describing the data. We have to have a main writer for making an inference, and then we have to have another main writer for taking action. So which ones do you guys want to do? And I'll write this down on our paper.
I'll do describe the data.
So let's see, what would you like to do?
I don't care. I could do take action.
Okay. That means I'll be doing make inference.
That's how you live your life. Yeah.
Okay. I'll put that down on here so that our teacher has that.
Do you know how long our things have to be? How long we have to write it for?
I'm looking at that right now. It looks like it's probably just going to be a Word document. Actually, I don't know. Let me look that up. It should say in your table of contents, if you go to the table and then go to the bottom, I'm just going to look and see. Let's see. Collect the data directions. So there's instructions that you'll use that you'll save, and then you'll use them as a Dropbox. So it looks like for like Jeremy specifically, he'll download this Word document that says, or that we'll download the Word document that says collect data. All of us will. And then, okay, so that one, yeah. I'm pretty sure what we'll be doing is we'll just be downloading the documents,
And just filling it in.
filling it in, and then just doing the rest.
Yeah, it doesn't look super hard.
And then we have to write something though, like
It's just a short summary of what you learned while collecting your data.
Yeah, I think the hardest part is getting
The data.
the project approved and then getting the data and then turning the data into our inference.
Okay. So what are we gonna do for our project?
So we got to decide. Our research question is basic, like we are trying to determine if. So this kind of comes down to what we want to do. Do we want to do like the library thing that I talked about, or what are the ideas that you guys had?
I like the dum-dum one of
What-
doing the ANOVA test.
What's done?
Yeah, so you doing either an ANOVA test or
I can't hear, guys.
sorry about that.
It's okay.
That one would either be an ANOVA test or a 2-sample test,
Okay.
because we'd be doing if we did a 2-sample test, we'd be guessing that, let's say we have a blue raspberry flavor or a grape flavor. We'd be saying our hypothesis is that they're the same, or for an ANOVA test it'd be the same or it'd be different. For a sample test, we'd be guessing that what is it? One would be greater than or less than the other. So we could do that one, or we could do a different one, depending on what you guys want.
because if we do that one, you have to do a sample. You have to go collect data too, right?
Well, I think we need to collect the data anyway.
All of us have to collect data, so all of us would have to be doing it, which means we'd probably figure out a specific amount of students that we want to hand out and then tally up which one's chosen.
Yeah.
So if we were to do this one, my idea would be that each of us would purchase the same amount of one color of sucker, whatever we pick to choose,
Mm-hmm.
for both of them, so that if we get all of the student sample size that we do, choose one color over the other. So we'd have to pick, like, let's say each of us do like 30 dum-dums of each flavor with each. So we'd have 60 dum-dums, 30 red, 30 blue. And then we'd have at least 30 students that we collect data from.
Yeah.
Or we would collect 30 students' data, and it'd be like a 50-50 each time to what they would choose. So once we've got 30 students done, then we just figure out how many each of us have of each color, and that would give us basically the preference over the other one, which one was better.
Yeah.
So we could hypothesize that blue flavor is better liked than the red flavor, and then we'd see if that holds true with that.
And then we could also have the option of not taking one. They prefer not to. Does that make
Yeah, that's
Because then we could just,
something that we need to consider as well.
yeah, if we did that, then it'd just be like an ANOVA test to see if there's a difference between ones.
Okay.
I like that idea. I think that's a good idea.
Mhm.
Okay, so
So if we're gonna to do that, do we just add the okay. Yeah, never mind. I'm just getting too far ahead of myself.
yeah,
Yeah.
no, that's a good.
I'm fine with whatever. But the thing is, we just have to make sure we all get the same flavors. That's the only thing. We have to make sure that we're all consistent. You know what I mean?
Yeah.
Yeah. Definitely. So we'll have
If
to
we do
decide.
that one,
We
Yeah.
have to decide what candy we get. Like we could do, we could even do it to where we just go out and get like a huge thing of Starburst,
Mm,
do 2 different flavors of Starburst, and then have another option of not taking one. And you
mm,
can do it that way too.
Mm-hmm.
yeah. So, Thomas, when did you say you were gonna move out? This
My wife
Saturday?
and I are moving Friday.
Friday. So, do you think
Yeah.
we should get together and buy the Starburst, or what do you guys want to do?
As long as we communicate what flavors we're getting and what kind we're getting, as long as we're like absolutely sure, we probably won't have to meet up necessarily.
Okay.
Because I don't want to have to like take other time out of your guys' schedules, and I'm trying to pack tomorrow and everything. As long as we're like certain on what kind of candy we want to do,
Mm-hmm.
we should be just fine. And I don't think it'll really matter. We don't have to say in our test like we're trying to compare between BYU and BYU Idaho,
Mm-hmm.
because this one I feel like would just be better just to do, students.
Yeah.
Students, what we're testing to see if they like this flavor over this flavor.
Or don't like it.
Yeah, or don't like candy at all.
Yeah. So
see, the idea that I had, remember I talked to you about, Thomas, it's we don't have to buy anything. So it's just like, it's a categorical one. Remember I was talking to you about it earlier?
Like the events that you were talking about?
Yeah. All it is, so I like to throw events and stuff like that. And basically it would just be like, there'd be like certain places, like, I think we could just ask one question, like, where would you prefer to attend, like, a certain type of event? And I would have it there. And then I'd create different places that people could choose from. And then we could base it off of that. We don't have to buy anything. I'll create the question and the options. And it's a super easy survey that someone just check marks something.
Gotcha. That's definitely an option too. What do you guys want to do?
It's like
So
super,
Celeste,
pretty-
you're what are you saying? You're like, where would you rather have an event held on campus?
yeah. Like, which would you more likely attend? Like,
Oh. So would you give them like specific options to choose from, or just?
yeah, I would give them specific options, and then there would be like another option where they can write in something.
Okay, that makes sense.
The only hard part about that is that I wouldn't be able to be there for the conducting of the study, because I wouldn't be able to do the same survey for BYU, but it doesn't matter to me.
Hmm.
Well, you could necessarily do it. It's not going to be specific places. Like one is going to be like at the school. It's going to be like a general. You know what I mean? It's going to be a general
Yeah.
category.
So what
Yeah,
is on the list?
What? Like for me, I would just put like, were you more likely to attend a dance party? And then like one would be like, at a, for example, like I would say at the school, like the school that we're attending, like at the school that we're attending, basically it would either be BYU, like here at the school, at a apartment complex, at a high school / middle school, something like that. Or then the other option is, or at other, just something else that they would write in. That would be the example. I would think of more things that are more general, but it'd be something like that. And then all they have to do is just check a box. It's like super simple and easy. You don't have to go out and get other stuff.
Yeah.
I don't know. That's just an option.
what do you guys think?
It's a good idea. What kind of test do you think that would be? A ANOVA test?
What was that?
Would that be an ANOVA test that you're trying to do?
I'm not for sure what that would be, though. That's the thing.
Yeah, I'm trying to think of that because that would be. Are we trying to see if there's a difference, or are we trying to see if there's one place that somebody likes more than all the other places?
Yeah.
I would say it'd probably be easier to see if they like one more over the others. And then what kind of test? That wouldn't be a ANOVA then, no? That would
No,
be
that'd be a two sample t-test.
yeah. So something like that. I don't know, but it doesn't require us to get grab. Like we don't have to. You don't have to like buy anything. It's just like a simple question, and then they just check it, and then you just collect all the data off of that.
Okay.
I don't know.
Would
That's
that
just an option.
Would that be considered a poll?
It's like a poll.
Okay. I think the teacher said if we're going to do a poll, we are required by federal law to get an IRB approved.
We have to get what?
We have to get a federal law IRB approval for a poll.
What is that?
I haven't looked into it. There's a video on Week 9's post that he put on there, but it says if you want to do a poll, federal law requires you to get IRB approval.
Hmm.
So would it be easier to do the dum-dum then?
Yeah.
Yeah.
Honestly, I would just do it as an IBC group. Say I'm an IBC group and just do it. I don't think I've seen like. Do you know how IBC groups just go out and do testing and stuff? I've never heard of them getting no IRB approval or anything like that. I'm just saying, but if that is, I'm fine with the dum-dum thing.
Okay. Yeah, it
I would
really
just say
doesn't matter.
survey. It's not a poll, so that way it's not under the category of a poll.
What would you say?
I said I would just say it's a survey.
Gotcha.
Do you know what I'm saying?
Yeah. Yeah, I understand that.
But we still have to get it approved by our teacher too.
Yeah.
I'm fine with whatever. Just like
I don't really care.
age. So
I was just saying that's easier to do. Like it doesn't require us to spend any money or anything like that.
But we're talking about Starburst though.
Or dum-dums or whatever it is.
Yeah. I
And then
mean,
you could eat them afterwards if there's extra.
exactly.
yeah, yeah, it doesn't matter.
It doesn't matter to me though.
I'm down for Dum Dum or whatever the snack
Okay.
idea.
I'll just put on here then that we're trying to determine if college students like one flavor of candy, of a specific candy over another. So we can decide what candy we want to use later.
Mhm.
I have to go in a couple minutes, but let's see. Like one flavor of a specific candy over another. And so we'd be testing with college students, so we'll probably just do it on campus at some point. Because I think, Jeremy, you said you're going to do that after, like during work sometime.
Yeah, I'll just do it during work.
Well, we
Okay.
have to. Do you think we'll hear back? Because it has to be approved before we can do anything, right?
Yeah.
Yeah, well, I'll submit it on Saturday. Well, I'll try to submit it before Saturday, and then he'll let us know. He'll probably just email me or he'll email us as a specific group and just let us know whether or not it's been approved or not. So I'll just make sure that I make this look really good on the actual document and upload it, and then see if it works out. And if it doesn't, we can always determine. He'll probably give us feedback about why he didn't approve it. So even if it's something like we just have to change something in our like design, then we can just change that up and then continue with it or something like that.
Yeah.
So this would probably be a I'm trying to think about this. Are we trying to say like 30 students chose blue raspberry over 15 students chose, cherry or something like that? If we did that, wouldn't that be quantitative or would that still be categorical? No, we're still trying to determine if one's better, so it'd still be categorical.
Yeah.
Yeah.
So would that then be a categorical test of one proportion? Like we're just going to get a huge proportion of students or huge sample size, and we're going to just collect all of it and then create a proportion from that. Is that what we're doing?
I think so.
Yeah.
Okay.
It seems right.
I just want to make sure I get this right before I do it. Okay, our experimental unit. In other words, what is the smallest entity from which you're collecting a single piece of data to be used for analysis?
Where are you at now?
A student and a piece of candy.
What number are you on again?
Question 3.
Okay.
Are you guys looking at this too?
I'm looking at it.
Yeah, I'm pulling it up.
Do you guys think we should specify male or female as well?
I don't know if that necessarily matters.
No, I don't think so.
I don't think it matters because we're not doing it on that.
Okay.
We're doing it specifically on the color, not on male.
I guess that'll be too much, right?
Yeah.
So I think we're doing random sampling.
Yep.
The reason why we're doing that is we're just picking random students. Or we're just going to have random students come up and take a flavor. Like we're not determining male or female. We're literally just getting 30 students. Doesn't matter their year in college. Doesn't matter their age. Pretty sure that would make it as random as possible.
Yeah, I think we're just. I think we're just doing just what people pick of flavors.
Okay. So the rest of the questions don't seem like too difficult.
Okay.
So what I can do is I can just kind of create this and then I'll send it to you guys via email, and you can let me know how it looks. And then if you need to change anything before I submit it, you guys can just send me a text message or something like that. Does that
Or
work?
just put it up on
Say that
like a
again?
Google Doc. Put it up on a Google Doc so that way we can edit it or anything like that if we see anything that needs to be corrected. So that way we can like be helping with it. Does that make
Okay. Yeah, I can do that.
Yeah.
Yeah, I'll do that. I'll put it up on a Google Doc today and I'll share it with you guys.
Okay.
Or I might do it tomorrow, but just
yeah,
be on the
whenever
lookout for
you do it, just whenever you do it, if you need help on it, we can add things in there too, like whatever we think, you know. That
Yeah,
way-
that's great. If you can just highlight whatever you add in a different color so I can see it, that would be great.
okay, yeah.
Sounds
Okay,
good.
awesome. I'll put the video up on the group collaboration, and then just for that email. Okay, guys.
Okay.
Okay. Sounds good.
Well, guys,
All right.
Okay,
Yeah.
take care.
see you later.